In this video, I will use Excel to conduct one-way ANOVA test using digital data. In this data, we are interested in to determine if there is a differences on average stopping distance between 4 different brake systems. So the data has been already saved in Excel as shown here. So now I will conduct one-way ANOVA. So before I use Excel, or before I get the result, what does null hypothesis for ANOVA say? The null hypothesis said that all the means are equal, all the population means are equal. So because here we have 4 group or 4 brake systems, so we start from 1 and stopped at 4 because we have 4 groups. Alternative said no, at least 2 of these group or brake system are different. So we don't know which one of them is correct. Is it null hypothesis or alternative using alpha 0.05? So we can conduct one-way ANOVA using Excel as these steps. First, I go to data, and then I go to data analysis. Then I select single factor, ANOVA single factor, double click. Then the question asks me to highlight or input the range of the data. So I highlight or copy all this brake system instead unless the car here is not the data, is just the idea or the subject. So car number 1, car number 2, and so on. So I just highlighted the data I'm interested in, and then they said for you grouped by Y, by what? So the data is already, grouped by column. And then they said, is the label in the first row? Does the first row here includes the label or the title of the data? And yes, I click yes. Then they ask me about alpha, so I write alpha here and then click OK. So here I have the ANOVA table. In ANOVA table, here we're having the count, which is the sample size for each group, the average of each group, and the variance. Here, this is the summary statistic table, but here is ANOVA table. So here we have the sum square between, sum square within, and their total. We have the first, the second degree freedom, and their total. We have the mean square between and the mean square within. We have if test, and also we called it if statistic test. We have the p-value, we have the F critical value or F alpha. So what is the decision rule in the F test or ANOVA table, ANOVA test? We have if F test larger than F alpha or F critical, which is 2.86 in our case. So this is not fixed for all of the data, but change from data to another. We reject the null hypothesis, or if the p-value less than alpha, we reject the null hypothesis. So from here, we can see the F test, which is 3.8, is larger than the F critical, which is 2.9. So we reject the null hypothesis. Also, we can see here the p-value is less than alpha, so we reject the null hypothesis. So we reject the null hypothesis. Okay, we reject the null hypothesis. So all the population means are equal. This is incorrect. So which should be correct? So it is alternative. At least 2 of the population means are different. So this is our conclusion. Because we reject the null hypothesis, we want to ask ourselves a question: who is responsible about this rejection? Which brake system is different from the other brake systems? We have to identify it. So how we do that? We use Tukey Kramer. So I have already explained during the class how to do Tukey Kramer manually using the critical range here, and we have to do it using this table. But if we, I will do the Tukey Kramer using StatCrunch. So I will close Excel here and open StatCrunch. So in StatCrunch, the data is already saved here. Okay. So how I do it in StatCrunch? So I just go to Stat, ANOVA, One-Way ANOVA. And then they ask me to select the columns. So I select all of them except car because it's subject. Then I compute Tukey with alpha 0.95 based on the alpha given in the question. You can change it. So, and then I press compute. Here we will have the table of ANOVA. The table from StatCrunch is very similar to the table from Excel, except the name here, columns, and here between groups, error within groups, and here we don't have the critical value using StatCrunch. We have to do it separately using the stat calculator and the F. So here we have the Tukey result. So we can see here from the first table here said break A subtracted from break B. That's mean the mean, sample mean of the first break minus the second break. And here we can see the differences between them is less than the range, critical range here. So because it's less than the critical range, the question is, are they different, significantly different? So is there a significant difference between break A and break B? The answer is no. But how I can do it easily in StatCrunch? So we can do it using the B value. So the null hypothesis said break A and break B are the same. Alternative said no, they are not the same. Null hypothesis said break A and break P are not significantly different. So here we can see the B value. B value here is larger than alpha. So because B value is larger than alpha, we accept the null hypothesis. What we accept that break A is not significantly different from break B, so the answer is no, the same as here. Now we have break A with break C. So here we can see the result of the differences between them is larger than the critical range. So does that mean there's significant differences between them? The answer is yes. When we come here to the B value, we can see the B value is less than alpha. So the null hypothesis said break A and break C not significantly different. Alternative said no, they are significantly different. So because the B value here less than alpha, so we reject the null hypothesis. Yes, there is a significant difference between break A and break C, so the answer is yes. So when we look at the B value here, if the B value larger than alpha, the answer no, there is no significant differences between them. If the B value less than alpha, yes, there is a significant differences between them. So when we are looking here, so this is larger than B value, so the answer no. Here is larger than the alpha, so the answer is no. Larger than alpha, the answer is no. Here is larger than alpha. So the only case we have, which is the B value less than alpha, so we reject the null hypothesis, it is between A and C. So yes, there is a significant differences between them. So we can see break 1 and break 3, there is a significant differences between them. But between break A and all the other breaks, there is no differences between them. And then we say, based on the Tukey, that break A or the first population and population C have different mean stopping distance. Because stopping distance preferred, so break C would be preferred over break A. Okay, so because they're looking at the stopping differences here, that's what they mean in these two sentences. Thank you so much.